In today's lesson, I'm going to talk about water cycles in the Amazon rainforest. This is for the OCR A-level spec 2.A, and we're going to look at the top 2 bullet points in terms of the tropical rainforest. So the main areas I'm going to cover are the rainforest water cycle and the physical factors that might affect stores and flows of water in the Amazon rainforest. Some basic things to start off with. It's the Amazon rainforest is in 9 countries, which takes up about 6 million kilometers squared. It's a huge biome, and 70% of that rainforest is found in Brazil. So this is the kind of conditions you would see in the tropical rainforest. We see that it's an area with very high humidity, lots of vegetation, and therefore that is going to affect our flows and stores of water in the cycle. So first of all, we're going to look at rainfall, precipitation. We can see here that there is a really high average rainfall per year, over 2,000 millimeters. And even though there is a dip in this graph, when I compare it to a place like Oxford, which is in a relatively wet country, we can see that there is no significant dry spell. There is variation, so March gets nearly 350 millimeters, but the lowest it gets is 50, which is significantly higher than a lot of places, and therefore we can say that it's a lot of rainfall all year round in places like the Amazon rainforest. We can also say that temperatures are also very high, so the average will be between 25 and 30, and again very little variation across the seasons, in the opposites of a place like Oxford, where we have lower temperatures in the winter and higher temperatures in the summer. So all of these factors, this high rainfall rates and temperatures, will affect the main processes in the water cycle. So because we have such intense solar radiation all year round, and this is the sun is concentrated over the equator, we are going to get the ground being heated up, and the ground will therefore heat up the atmosphere above it and cause that air to rise, the parcels of air to rise, which will then condense and turn into rainfall. This process of the ground being heated up, heating up the air above it, which then rises through the atmosphere and turns into clouds, is called convection. And so most of the rainfall we get in the Amazon is convection rainfall. Because we've got such high temperatures in the Amazon, we're also going to get really high evapotranspiration rates. We know that when the temperature goes up, the evaporation rates and transpiration rates go up. And so in the Amazon, 60% of that rainfall that is actually falling gets recycled from the biosphere back into the atmosphere. Also, because we have got a lot of rainfall, we're going to get a lot of growth, because we know that we need water for photosynthesis. So we get really dense vegetation in what we call evergreen trees, which means they don't lose their leaves all year round. And therefore, because we've got dense vegetation with trees that don't lose their leaves, we get really high interception rates. And actually 20% of the rain that's intercepted by the trees goes back into the atmosphere, is evaporated. So what we're actually seeing here is this cycle where water is rapidly cycling between the atmosphere and the biosphere. It's a really rapid kind of movement of the water, and it's a feedback loop. So when it rains for a long period of time, because the temperature is going to go so high, they are going to feed that back into the atmosphere, which causes more rain and get more rainfall, and again we're going to get more evapotranspiration, and it's feeding itself in this regular cycle. I'm going to talk a little bit about how the atmosphere has such a large amount of water vapor. We need to look at it at an individual tree level. So the water from that intense precipitation is taken in by the roots. It's then fed through the stem, and eventually it will leave the tree through transpiration. But really what's interesting is actually as that water leaves, it kind of leaves this kind of these bits of dust. So particles are a part of that rain, the kind of water leaving the tree. So we've got little particles, so bits of salt, and what they actually help to do is they actually help to make the clouds condense, because what the clouds needs and the water droplet need, they need something to condense around. So having kind of a bit of salt or something that's come out of the tree will actually help it to condense better. So because we're actually getting lots of water coming actually out of trees through the process of transpiration, they're taking up all these particles, which is actually again allowing it to condense quicker and make these clouds quicker, and therefore that rain is able to fall out of the sky. Again, this is a feedback loop that is kind of happening between the atmosphere and the biosphere. Once that water has actually made itself kind of into the biosphere, it will eventually kind of flow through the trees in terms of things like stem flow, and some of it will make its way to the ground, and that tree will actually exit the drainage basin through something like the Amazon River. So the water doesn't just stay in the Amazon, it eventually will go into the ocean or other drainage basins via things like the river flow, like the Amazon River that we can see here. As you can see in this picture, we kind of touched on it earlier on, but it's very, very kind of misty, and that is because the temperatures are so high that we have got a lot of moisture being stored in the air. That is because we know the idea that absolute humidity means the amount of water that can be stored in a parcel of air, and when temperature goes up, the absolute humidity goes up. So the warmer the air, the more moisture it can actually hold. I'm now going to move on to talk about physical factors. I'm going to start with geology. So we've got an image here of the kind of geology of Brazil, but this is a kind of reflective of also geology that can be in other parts of the Amazon basin. So the yellow is the sedimentary basin, and the red areas are what we call crystalline shields, and I'm going to come down to that in a second. So these red areas of crystalline shields, these are big areas of igneous rock. They were formed kind of through tectonic activity, and it creates these rocks made of very, very tight crystals. That is significant in terms of the water cycle because it basically means they're impermeable, and therefore if there's large areas of the Amazon basin that is made up of these crystalline impermeable rocks, then you're going to get rapid runoff rates. These yellow areas, however, they're made up of limestones and sandstones, and they are porous and permeable, and therefore the water that falls in that area is going to kind of sink into the ground. It's been able to infiltrate, and therefore it's going to end up in aquifers and reduce the runoff rate. So depending on the geology of the Amazon basin, in different parts you're going to get different runoff rates and different infiltration rates. As we can see, a lot of the basin is made of that crystalline rock, and therefore there's going to be kind of rapid runoff rates. Relief is also really important. We talk about the topography. So a large section of the Amazon rainforest is lowlands, and that means therefore the water is able to move either through the soil as through flow, it's able to infiltrate and go down as ground flow, and when it's really intense it will move over the surface as overland flow. However, in the west of the Amazon basin, you're going to have slightly different. You're going to have much higher surface runoff rates because the relief is a lot steeper there. And that means you're going to get, in those catchments, huge runoff rates compared to most of the basin, which is actually got a lower relief. Last thing I'm going to talk about is temperature. We've kind of highlighted this a little bit already, but where I get high temperatures, I get this high amounts of evapotranspiration, I get really high humidity, absolute humidity. That means the air can hold a lot of water. When there's lots of water going into the atmosphere and the air can hold lots of water, then I'm going to get lots of water vapor in the atmosphere. When there's lots of water vapor in the atmosphere, I'm going to get lots of condensation, which is going to lead to rainfall. this is really significant. We talked about how it cycles quickly, but when I get lots of clouds and an air full of water vapor, this is going to not stay still. It's going to be moved around by winds. And when this is moved around by winds, we're getting transport of water between basins and between areas. And a really significant thing in the Amazon rainforest is this thing called flying rivers. And we can see here that the wind patterns move moisture, and they move these clouds around the Amazon, and they're kind of spreading that water across different parts of South America. So flying rivers are really significant, and actually if we look at in terms of what they can hold in terms of water, there's more water held in these flying rivers above the Amazon actually than there is in the Amazon River itself. So there's a really significant thing to think about, and especially when we come on to talk about deforestation rates and how that might alter things like the flying river.